Hello, today we shall learn how to control this OLED display with the Arduino Nano and how to display images and animations on it. So let's get started. Here you can see that there's a man dancing a rather fun and a rather weird dance. And you can also see that there's an Arduino Nano connected via 4 wires to the OLED display. Let's look at the wires in detail now. So then there's this 5-volt wire which connects the 5-volt of the Nano to the VCC of the OLED display. Then there's the ground wire which connects the Nano to the ground of the OLED display. Then there's a wire that connects the A4 of the Arduino Nano to the ST of the Arduino display. The OLED display. As you see, A4 is the STA pin of the Arduino Nano, and then there's another one that connects A5 to SCL. For A5 is the SCL pin of the Arduino Nano. There are also 2 wires coming from a 9-volt battery's plus and minus battery connectors, plus and minus wires, which go to the Win pin and the ground of the Arduino Nano and provide the circuit with power. So now let's look at the code to display this animation. Alright, so here's the code. This code is quite big. It has 164 or 100 lines. Yep, it's 164 lines. And let's go over the code in detail. So here we have include wire.h, which is a library needed to control all I2C devices. It comes pre-installed in the Arduino IDE. Right over here, Arduino libraries wire. There are 2 more libraries that we need, which do not come pre-installed: Adafruit GFX library and Adafruit SST1306 library. These 2 libraries are necessary to control the OLED display, but the good news is we can easily install them from the library manager. After that, we are starting the display, and then we are defining 2 bitmap arrays for storing the 2 images needed to create this animation. Now let's look at the functions. So here we have got the setup function. It starts the display here. In this line, it starts the display at I2C address 0x3C, which is a default for these sort of I2C displays. And then it clears the display. In loop, we do a set of things. First, we clear the display. Then we display frame 1 on the display. And then we display the display. This sounds quite weird, but you have to display the display after you finish drawing everything, otherwise it does not come on the display. After doing these 3, you have to delay for 100 milliseconds, and then we do the same with frame 2. Now that we have gone over the code and understood it, let us learn how to create these quite big and weird image bitmaps. Alright, so here we have an online bitmap conversion tool, image to CPP. This is the tool that I have chosen to use to convert all the image files into bitmaps. Let's try it out with this file. Okay, I'm going to remove this one and I'm going to select the resolution as 128 into 64. I've selected this resolution, stretch to fill canvas. These are the default settings. Stretch to fill canvas should be selected, and we get this image preview. Now I can select Arduino code here, remove this, and I can click generate code, and voila, we have got a bitmap of our own. This bitmap can directly be copy pasted into the code, and if you don't like the names, you can change it. You can change the names because these are plain text boxes, like that. And now let's try it with a different file. Click here, choose files, and animator 2. I'm going to remove animator 1. I'm going to click here 64. Stretch to fill canvas, same settings, and here we've got the other image preview. And when we click generate code, we get the other bitmap. Both of these bitmaps can directly be copy pasted into the code and used to display the images. Alright, so in this video we learned how to connect an Arduino Nano to an OLED display, how to write the code that interfaces an Arduino Nano OLED display and displays bitmaps on the OLED display, and how to create bitmaps from images using image to CPP.